Alright, so in this video I'm going to explain the proof that the square root of 2 is irrational. This is probably one of the first problems you will encounter in the first course on mathematical analysis. I know from my personal experience that when I took real analysis in university, my lecturer began the first class with this problem. So a bit of background. If you type square root of 2 into a calculator, you get something like 1.4142. The important thing to note here is that the decimal does not repeat. And this is one of the characteristics of irrational numbers. They cannot be expressed as a repeating decimal. The irrationality of the square root of 2 is probably best associated with the Pythagorean theorem, the one concerning right triangles. And that's because Pythagoras and his followers believed that all numbers were rational and can be expressed as some form of fraction of integers, no matter how large the integers are. So if you put any fraction into a calculator, it produces a repeating decimal if it doesn't divide evenly. For example, here with 5/11. The problem with the Pythagorean theorem came when one of his students presented to him a triangle of equal sides 1 and asked what is actually the length of the hypotenuse. Now naturally, if you use the theorem, you'll get that the square of the hypotenuse is 2, which means that the hypotenuse has length 2, the square root of 2. However, what the Pythagoreans discovered was that you cannot express the square root of 2 as a fraction of two integers, and you can only approximate it with decimals. Hence, they had to conclude that the square root of 2 is irrational. Now, allegedly, the student who presented this problem was thrown overboard a boat and drowned, but that's a story for another time. So now here's the proof of why you can't express the square root of 2 as any fraction of integers. Now this type of proof is called proof by contradiction, where we initially assume that the opposite is true and then try to deduce why the logic doesn't work. So let's suppose that the square root of 2 is rational. Well, then we can express the square root of 2 as a fraction of integers, say a over b. Now I want to stress a couple things about this fraction in particular. One, we are assuming that both a and b are integers and b is not 0 because obviously. And two, we are also assuming that a and b have no common factors. And that's because that if they did have any common factors, we could just factor them out and reduce the fraction, again having another a and b. Now this second point is more important and we'll come back to this later. But for now, let's apply some basic operations. Now we can square both sides. And by doing that, we can bring the b squared term over, which leaves us with a squared equals 2b squared. Now this means that a squared is even, and in return, we can say that a is even. Now this comes from the logic that squaring an odd number gives you another odd number. And if you square an even number, you get an even number. So now we've deduced that a is even. All right, so before we continue, I'm going to leave the important point from the previous slide. We are assuming that the square root of 2 can be expressed as a fraction of integers, a over b, where a and b have no common factors. Now, we have established that a is even, so that means that it is divisible by 2, which means that we can write a as a multiple of 2 times another integer, for example, k. So let's substitute this back into the original equation, a squared equals 2b squared. So we get a squared, which is equal to 4k squared, which is equal to 2b squared. But we can divide that by 2, and we get 2k squared equals b squared. Now, this implies that b squared is even, and by the same logic, we can say that b is also even. But wait, if both a and b are even, then they have a common factor, which is 2. Now remember that we started this line of reasoning by assuming that a and b have no common factors. But now we have deduced the opposite, which is logically impossible. A and b can't have no common factors, but at the same time have at least one common factor. So we have to conclude that the opposite of our initial statement is true. The square root of 2 cannot be expressed as a fraction of integers and is therefore irrational. And that's the proof. I'll add a QED at the end, which is the notation for completing proofs. That's just my habit. Other mathematicians have different notations. But anyway, I hope that was a clear explanation of this proof, and thanks for watching.